Okay, so it is time for a challenge. Now, this is only going to be a real small challenge. So there's no coding necessary, but I'm going to type the challenge in so you have it on the screen, and then I'm going to just talk through it because it's something that's pretty important. And after this, after we've gone through the answer, I'm just going to demonstrate the concept. So what I'm going to do is create a new class now. I'm going to call it challenge because that's why we're going to be typing some of the code, or this code anyway. I'm going to create a new class called challenge. Whoops, and I've called that the wrong thing, so I'll just refactor that. Rename it and get rid of one of the L's. Like that. Okay, that's better. So let me paste it in. Okay, I'm going to paste the code in. So here is the challenge. So when overriding the equals method in the heavenly body class, we were careful to make sure that it would not return true if a heavenly body was compared to a subclass of itself. Now, we did that to demonstrate that method, but it was actually unnecessary in the heavenly body class itself. So your mini challenge is just a question, and that question is, why was it unnecessary to do that for the heavenly body class? And just a hint there, if you're stuck, check out lecture 97, because that goes through what the issue is and why in this case it's not necessary. So pause the video now and see if you can just have a bit of a think and figure out why that's not necessary, why it's not needed, and if necessary go back and review heavenly body, the code, and when you're ready to continue, start the video. Pause the video now. Okay, so how did you get on? Hopefully you figured out the answer to the question, which was, why is it unnecessary to do that check in the heavenly body class to make sure that it wouldn't return true if a heavenly body was compared to a subclass of itself. So I'm going to paste the answer in here, and then we'll talk about it. And as mentioned, we're going to go through some code and the answer. Okay, so there we go. There's the answer. The heavenly body class is declared final, so it can't be subclassed. So of course we didn't need to do any tests to check the subclass because we already know that it was marked final. And in addition, the Java string class is also final, and that's why which is why it can safely use the instance of method without having to worry about comparisons with a subclass. So that's the answer to that. Hopefully you figured that out. And again, if you're unsure, check out lecture 97. But you might be looking at it and thinking, well, why is it an issue with using instance of and subclasses? So what I'm going to do is create some additional code now to show you and outline what the problem is. So we can actually do this in this code, in this class. You can create a new project if you want, but I'm just going to put it all in this project. So I'm going to create a new class. To start off, I'm going to call it dog. Dog's going to be our base class. And we're going to have a final field. Private final string name. I have a constructor which accepts that as a parameter, and we're just going to have a getter for name. So the actual equals method that we're going to write, we're going to override it. So I'm going to do my control O and override equals, and instead of that return, I'm going to delete that, and I'm going to put firstly if this is equal to object, return true. Remembering that we do that to test whether this object is being compared against itself, and if that's the case and it's the same object in memory, we know that it's always going to return true using the equals. So if that's the case, yeah, we return, as you can see on line 20. But next we want to do if object, which was the object that we're comparing, instance of dog. So is it the dog class? Then we're going to put string object name is equal to dog, converting or casting a dog to the object to a dog. Dot get name. Then we can use the string equals this dot name dot equals object name. Okay, so that's the case, and we've determined that the strings in the classes are the same, and it is the dog class that we're actually comparing. If that's the case, we get the string. We use the string equals to actually test whether the strings are the same. But if we get this far down, we know that they weren't the same, and we're going to return false. So next we're going to create another class now. We're going to call this one Labrador. And we're going to extend or subclass dog. And we're going to create a constructor first. The constructor is going to correctly call the super to set the dog name. And we don't need to do anything else other than the equals. So what I'm going to do with the equals, I'm just going to copy the equals method from dog. And then we're just going to make a change. A couple of changes. So I'm just going to paste that in. So there's our overridden method for equals. And the only change I'm going to make is the references that are to dog, I'm going to change to Labrador. So I'm going to take a copy of the class. There we're going to change that to Labrador and object name to Labrador as well. And so it's now testing correctly for this class instead of its superclass, which was dog. And name's not going to work anymore, and that's because we haven't got a field in this class and we've set it to private access. So we're going to change that and just use the .get name so that we can actually get access to the name that was saved on line 9 when the constructor was actually called. You can see now it's correctly comparing Labrador. And we're going to create yet another class, and we're going to call this one, we'll call it dog main so as to not confuse ourselves with the original main class that we used earlier in this set of videos. Call it dog main. And we're going to create ourselves a main method so we can actually run it. So we're going to type psvm and press tab. There's our main method so we can actually call it. So we're going to create a pet Labrador called Rover. So Rover is then found wandering by the dog warden who reads her collar and decides that she's a dog called Rover. So let's do that. So Labrador Rover equals new Labrador Rover. We're going to type dog Rover 2 equals new dog Rover. So we're very distraught at this point at the loss of our pet, so we're going to phone the dog pound to see if she's been found. Now they have a dog, and the dog is called Rover, but is she our pet? Well, that depends on how you ask the question. So what we can do here, just in programming terms, to answer that question, we can put, firstly, does Rover 2 dot equals Rover? You can see Rover 2 is the dog, Rover on line 8 is the Labrador, and the second test will be, we're going to put does Rover dot equals Rover 2. See what we've done? So we've done the first one, we're testing Rover against Rover 2. The second one, we're testing Rover 2 against Rover. So firstly, we run that. And of course it doesn't work because it's executing the other class. So I'm going to right click it again, run. So I'm going to click on run dog main. So you might be interested to see that in the first case, Rover 2 equals Rover, but in the second case, we got so return true for that first one, but on the second one on line 12, Rover equals Rover 2 return false. So basically what's happening here is that a Labrador is an instance of dog, but dog though isn't an instance of Labrador, so the second test returns false. So this violates that symmetric rule that we talked about, that an equals method must obey. So basically it has to be equal on both sides of the coin. So in this case, Rover 2 has to equal Rover if we're testing that way, but the other way around as well, Rover has to equal Rover 2 for that to be true. So we can fix this because this is obviously a problem at the moment. So we can, the best way to fix this is to not override the equals method in Labrador. So we can remove that code. So we're going to remove the lines from Labrador. So I'm going to go back in there and do that. So I'm going to basically comment out this code in the Labrador class. So we're not going to override equals at all. So I'm commenting that out completely. So that should now that we've done that, if we go back to dog main, we should allow us to find our pet regardless of how the question's phrased. So we'll just run it first to confirm. Notice it's now true in both scenarios. Because we're not overriding that equals, it's now set to true in both cases, whichever way the question's phrased, in other words. Now, to ensure that equals can't be overridden in subclasses of dog, what we want to do to confirm that would be is we actually want to go back to the dog class and mark that as final. So we'll put final. So we're marking it as final when we're saying that this method cannot be overridden at that point. So that's one way to really make sure that the equals can't be overridden and we can't get into the problems that we just had. So what we could do then is go back to Labrador, and if we try and uncomment this code, we're now going to get an error, and basically it's saying the overridden method is final, so we can't do what we're trying to do. So that's the message we want in this case. So I'm just going to comment that again, and we'll just do one other test to make sure that's still running, and we're still getting true for both. So what this should highlight is that it really does show that a great deal of thought is needed when you're overriding equals, and of course therefore hash code. So should you allow your classes to be subclassed? If so, how do you treat comparisons between a subclass and its base class? So if the subclass would reasonably only add methods that do not alter the way that equality should work, then allow subclassing, but mark your equals and hashcode methods as final. Now, if a subclass is likely to be a different object, then use the method we use in Heavenly Body to make comparisons between the subclass and its base class return false. So if neither of these would really fit, then prevent subclassing and force clients to use composition instead. So we've now seen how to implement a mutable class that can be safely used as either a key in a map or as an element in a set. The Heavenly Body class isn't immutable because we can add moons to it, but any change we make to it won't affect either the behavior of equals or the hash code that is generated by its hash code method. And it's worth pointing out that these videos have been about sets and overriding equals and hash code and not about how best to model the universe. So keep that in mind, that it's an important distinction there. And the example using planets was chosen really because it involved objects that naturally form sets, and so it was quite good for demonstrating sets. And also because I wanted to have sets of objects rather than primitive types so that we could look at equals and hash code. Now there's a definite is a relationship between a heavenly body and both a moon and a planet though. So if you were really modelling the universe, it would probably be better to extend a base class to create the different types of objects found in space. Now sets could still be useful though, so if your program was used by someone investigating ice giants, for example, then it could be useful to group that kind of planet into its own set. And a planet object could maintain its own set of moons and could then be used in a union to allow all the moons in the solar system to be grouped together, as we did, of course, in the example. So that's it. I hope you've got a lot out of these few videos. In the next video, we're going to look at set, intersection and difference, and then we're going to finish with a meaty challenge. So I'll see you in the next video.